Hello everyone, my name is Benjamin and today I am going to talk about ionic bonds and covalent bonds. Before we start talking about ionic bonds and covalent bonds, we have a few terms that we have to understand in order to provide a basis
from which we can be able to understand ionic bonds and covalent bonds. A few terms that I'd like to define before we start our discussion are: one is matter, second term is element, atom, molecule, and compound. Matter is anything that occupies space in the universe. Matter can be liquid, it can be gaseous, or it can be solid. So pretty much it's anything that occupies space in the universe. When you break down matter, you can be able to see distinct characteristics between the components of matter. You break down matter to very small particles that you can be able to see the difference. For example, if you break down a piece of metal, you can break it down all the way to the extent that you can be able to use a microscope to see the components, the small particles that make up the whole metal. So those small particles are the ones we call elements. So in other words, elements are subunits of matter, but they are so small and microscopic in such a way that you cannot be able to see with the ordinary eye. When you break down further those elements, you come up with atoms. So atoms are the subunits of elements. Now, atoms are very minute and they are composed of negative and positive charges. We are going to see in a moment the structure and the charges, how they are distributed in the atom. But then just for now, understand that when more than one atom reacts, when two atoms or more react together and form bonds, which are actually ionic and covalent bonds, they come up with bigger elements out of that reaction, and that bigger element that they come up with, which is bigger than the atom, which means that it has more than one atom, are called molecules. So more than one atom reacts to form a molecule. And when more than one molecule reacts, it forms a compound. A good example of compound is sugar, glucose. Glucose is a type of sugar that has 6 atoms of carbon and 12 atoms of hydrogen and 6 atoms of oxygen. So like for instance, the formula for sugar is 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. That one is glucose, which is a form of sugar. So pretty much that is what we mean by molecule and compound. Now let's move on and look at the structure of an atom. An atom, whether it's an atom of a sodium molecule, or rather a sodium element, or it's an atom of a hydrogen element, or it's an atom of carbon element, all the elements, the atoms of all the elements look the same in structure, but they are different in the number of electrons and the number of neutrons and protons, and the way they're distributed and the kind of bonding that they can form. They are different, but the basic structure is the same. What I mean by the basic structure is that the central part, this is how an atom looks like. The central part of the atom contains protons and neutrons, and around the central part, or rather around the nucleus, so this central part is called the nucleus. Around the nucleus we have electrons. Electrons are distributed in orbits. So like for example, if it's 2 electrons, usually the innermost orbit or the innermost layer will take only 2 electrons. So the innermost layer is going to take 2 electrons, and the next one after the innermost is going to take 8 electrons, and subsequent ones are going to take 8 electrons. That's how the distribution of electrons are in the atom. So this is the structure of the atom. You have the nucleus, You have the protons, which are in the central part of the nucleus. You have the neutrons, which are together with the protons in the central part in the nucleus. And then we have orbits. That is electron orbit. So those orbits are the orbits in which the electrons do circulate. Alright, next let's move on and see an example of an atom. We have an oxygen atom, for instance. An oxygen atom has 8 electrons, and that makes up the atomic number of the atom. So like for example, hydrogen has 1 electron, so the atomic number of hydrogen is 1. Oxygen, for example, has 8 electrons. Atomic number of electrons are 8. So if you go to the periodic table, you can just Google periodic table. It will be able to give you a breakdown of all the elements that have been categorized by scientists. So this is the basic structure of an oxygen atom. Another structure, another example is the hydrogen atom, which has 1 electron. The way I said, inside you have 1 proton, you have 1 neutron, and then you have 1 electron outside. Always remember, the number of protons, number of electrons, and number of neutrons are going to be equal in the atom before the atom reacts with any other kind of chemical to form bonds. All right, let's move on to the next subtopic, which is going to be definition now of what we are going to be talking about today. We have ionic bonds and we have covalent bonds. So what are actually the ionic and covalent bonds? Someone may ask. Ionic bonds are the type of bonds that are formed between atoms as a result of transfer of electrons. So in ionic bonding, there is transfer of electrons from one atom to the other. On the other side, the covalent bonds do not involve transfer of electrons. Instead, they involve sharing of electrons. You find that one atom shares electrons with another to form a covalent bond. But in ionic bonds, electrons are transferred from one atom to the other.